Hello everybody. Okay, on this video I have added a clamp on this side of the system, the steel inner clamp, and I don't have one here. It's not mounted on. So I want to make power the group of 8 coils with the 60 volts and um, measure with the strength meter, Gauss meter, the strength around this area compared to the strength on this area here, and the final measurement on this clamp right here compared to this clamp and this clamp here on this side. So when you turn on this meter, by default, it starts on micro Teslas. You have to press again to set it to Gauss. So the other thing about this probe is that it gets the best reading when the flux lines, the imaginary lines, are perpendicular in a 90-degree angle with the sensor. That's the maximum readout. Now, if you put it forward here, you'll get the less reading because the flux is going this way, and what you get in parallel to it. So the best reading, you're getting it around here on this space area. You don't have to actually touch the coil to get it. So around here, you will get it because it'll be about the perpendicular on it. So I'm gonna power it up, and so we got 1 amp exactly there, and I'm going to measure it right here. Are we getting somewhere around 79, 80 Gauss, and here we got 124, and here we got 150, somewhere in there. So now we go over here, and we see the difference right here, 57, 56, and here it's 90 and 107th, which is where the clamp used to be. Right here I got 146, and if I go here I got 205. So obviously the strength is concentrated on this area rather than here where I have 106. And on this clamp I got 156 around here. When I come here, I got excuse me, I got somewhere around 150. Yeah, you gotta look for the angle that it gets the right measurement. So, but you see, if I go from here and 80 and I start traveling, you see an increase ascending until it gets to still at 126. 170 versus 88. Now here I have 76, and as I further away it gets closer to the steel, it goes higher, but it's never as higher as here and as here. So this is this test, Of course, this has to be done more. The more testing you do, the better. And you have to write them down and put the positioning of the sensor. And so you build a gradient on time on the space that you're measuring it right here. See, right here, I got 203, 206. Right here, I got 230. And here I got 224. If I touch the sensor right here, 250, 60, 75. If I go here and put it right here, I got 274. And here I got 199. Versus here, I got 218. So here is 161, and here 168. But here, it's just where the clamp used to be, I got 187. 187, 183, and here I got 239. So basically, it gives us a view of the concentration of the field on this area. If I move it here, then it'll supposedly be much higher, 330, and here it'll be 319. And this is 472. So this is what we're looking for. We're looking for a gradient. Oh, it went off again. Gotta set it back on Gauss. So if I get it right here, I got 104th on the south here. 224 versus here 300. The max that it read 394. 430, and here where there's no clamp is 114 on this area, 130. So, and here it's 257. So we see the bigger concentration on this area here. And this is good because at the time that it starts sequencing, it without this clamp on here and just the attraction on this clamp, it'll induce the secondaries with a stronger gradient of force, of magnetic force, rather than with the steel clamp here. All right, guys, thanks for watching.